Okay, so let's take a look at another way of combining functions called composition, which is sort of unique. Composition of functions is written like this. Let's say we're going to compose the functions f and g. So f circle g, it looks kind of like fog, of x. So x is the input to this function, f of g is the way it's read. So f of g of x. And the definition of f of g of x is literally f of g of x. Okay? So you can imagine if we didn't understand this notation, we should definitely understand this notation because it's simply function notation repeated twice. So for example, let me give you two functions f and g, and we'll see how this thing works. Okay, so here are two functions, f of x and g of x. And what we're going to do is we're going to find f of g of, let's say, 1. So f of g of 1 is literally f of g of 1. And I always write the 1 inside smaller so that I understand this whole thing is the input to my f function. Okay? So if I want to know f of g of 1, I first have to input 1 to g. So I go find my g function, and I input a 1. Every place there's an x, every place there's an input. So this is the same thing as f of g of 1. G of 1 is 1 minus 3. Right? Or if you wanted, we could do that off to the side. We could say g of 1 is 1 minus 3, which is negative 2. So I'm going to replace g of 1 with negative 2. Right? This whole thing, g of 1, is negative 2. Finally, I will take and input negative 2 to my f function. So now I look at my f function and replace this input with negative 2. So I get 2 times negative 2 plus 1. So that's negative 4 plus 1, which is negative 3. So the conclusion is that f of g of 1 equals negative 3. When I input a 1 to this function, I get an output of negative 3. So that's just a basic understanding. You can see what's happening here with numbers. Let's find, let's do something with f of f, for example. You can also take f composed with itself. So for this, I'm just going to say let's find f of 4. Okay? That's the same thing as f of 4. So the first thing I want to do is determine the value of f of 4. So I plug 4 into my f function. That's 2 times 4 is 8, plus 1 is 9. So this is the same thing as f of 9, because f of 4 is 9. Now I have to find f of 9, which means my input to f is 9. So I go back to f, the input's right here, plug in 9, 2 times 9 is 18, plus 1 is 19. So f of 4 is 19. Okay, finally, let's look at f of g of x, where the input could be x, not just any particular number, but a variable x. Okay, so I've already written it out here. F of g of x is the same thing as f of g of x. We do the same thing. We first determine g of x. So every place I need to put x as my input. G of x is x minus 3. So I literally write x minus 3 because that is g of x. Now I take x minus 3 as the input to my f function. So x minus 3 is going to be my input here. So I get 2 times the quantity x minus 3 plus 1. And if I wanted to simplify that, I could distribute my 2 and get 2x minus 6 plus 1, which is the same thing as 2x minus 5. So f of g of x is 2x minus 5. So if my input is x to the f of g function, the output is 2x minus 5.